And so there we go. We're recording, and now I'm gonna find my screen sharing. Okay, everyone see that? Okay. So broodstock conditioning and spawning, how we turn 30 oysters into a couple million in short time. So we're going to go through that. And when we talk about broodstock, we're talking about selected adults that we want to use to bring in our new SPAT. So we literally choose a number of whatever we want to spawn. This week we spawned clams and oysters. Clams for the clam project, and oysters for various things, including SPAT. And so, these clams or the oysters that we choose are they can be random, but we want to select them with some criteria that we're going to go through. And these animals that we're pulling in to spawn, we're tricking them the entire time into thinking that it's spring. So I'm going to show you how we do all this stuff. Oh, and by the way, if you have any questions as we're going along, just unmute yourself or chat me, and I'll see that. I'll see that. There's my chat. Okay. I'm still learning all this stuff. Darcy's teaching me everything I know. Hi, Darcy.
Here.
Okay.
I'm having a little trouble hearing you. Is anyone else having any trouble with the audio?
So you're not hearing me?
You're just a little bumpy, a little broken up.
It's sad because I have a new microphone and apparently it's not working. Let me just. This one's not on. You're not hearing that. It didn't get better. Okay. Somehow I hit the wrong button when I said computer. Is that better?
Maybe.
Is that better? No?
I think so, yeah.
How come we get two different pictures here?
I don't see anything I can change my audio with. So, how bad is the audio? Terrible?
That's pretty bad.
Yeah.
I'm not sure what I can do to fix that right now. You know what? Maybe I can.
I lost it here now.
You
Still
see me?
there. Can't see you.
You can see me?
No.
No video.
I've got an issue. I wonder if I have to restart everything.
You can give me control of the meeting and then it won't end and then you can join back in, I guess.
Okay, let me do that. Let me start over again.
Okay, if anyone loses, yeah, if anyone gets kicked out, just rejoin, but.
How's that? Is that better?
Yes.
Think so.
Yep.
Darcy.
Okay, I guess we can start again. Am I still recording? Still recording. Okay, let me share screen and here we go. We back online, everything's good?
I hope so. Yeah, if we mute everyone, maybe that'll be good too.
You can hear me better now?
Not really.
I think it's about the same.
Yeah, it's about the same. Yeah, it's very staccato.
No better, huh? Okay. I don't know. I'll
We'll have to suffer through.
But you can hear me enough that we can do this. How's the wine? Everyone's got wine, so you don't really need to hear me. It's so good. Let's go through it. So some of the criteria that we use include color morphs, which we're going to talk about. Some of the traits can be disease resistance, such as in oysters, we've got dermo and MSX and roseovarus, which was the old juvenile oyster disease. We can talk about the disease resistance. Fast growth, these things we can select for with our broodstock. And so, for instance, in color morphs, in these clams, these here are what are called nototic clams. You see my cursor, right? Is the cursor there? Yeah. Okay, so it's purple, white, purple, white, purple. And here kind of looks like a Charlie Brown shirt or an Indian blanket design. And again, it's very bold purple, white. This is what's called a nototic clam. And it's our regular clam. It's just a subspecies that has this color morph in it. And so if you want to use these for in a hatchery situation, you can get them to be pretty much 100% notata. The clam project that's going on, they don't want these clams. They want white clams. They don't want to use notata clams, even though they are naturally occurring in the population. Was that a question, or was it a... And so when they're purebred like that, they're what we call homozygous notata. And if we breed a clam like this one, this nice dark purple, white purple clam with a white clam, you might get the offspring to have a lot of this chatter, this kind of, they're not going to all come out looking like this. Some will be white, some will be this, some will be in between. But if you keep breeding these homozygous, you're going to get 100% of them to look like that. Has anyone ever gone to Florida and bought a bag of clams, or South Carolina? You would see 100% of them being very dark nototic clams. And why would anyone want to use them? Well, if you plant them out in the wild, you can get a little bit of an idea how your plantings are doing, because it's almost like a genetic marker. It is a genetic marker. So some enhancement programs don't want, they're thinking that you're changing the genetics of the beds if you use these, so they want to stick with your natal white plants. But if you're selling them for market, if you're a commercial clam grower, you pretty much see these notatas throughout. Now, folks that have been in the SPAT program a while might remember this black line that runs up the oyster. It's this black stripe that runs up the oyster. And that's an interesting color morph, because when this was kind of, it's naturally occurring. It's not like somebody gene spliced it in there to have that black line. But what happened was, back in the early 90s, Frank M. Flower and Son, big hatchery in Oyster Bay, they had a tremendous die-off of their new oysters before they reached the size of a dime. These tiny little oysters, they got 90% of them died. That I think it was 92 was the first year, where 90% of their stock died, and they didn't know why. And so in their wisdom, they took some of the 10% of the survivors and bred them. And the following year, they had about 50% mortality. And so they kept breeding survivors until they bred that mortality out of the system.
On the news program the first night of the crisis, and
Is that a question, or is that somebody who's not muted?
Yeah, Karen's iPhone. You can mute it if you want.
just mute yourself there because you're, anyway. So while they were breeding this mortality out of their oysters, they also happened to have used stock that had this black line. So after a few years, all the seed that you got in Long Island from these hatcheries had this black line running up. So
Yeah, I don't know if we sold, but good happens. Saying rain,
Oh, well, text and see.
I can't while I got this on.
you gotta mute yourselves.
Kim, you can mute that person. I don't, maybe they don't know how to do it. You can hover over the picture and hit on the 3 dots and mute them. There you go.
Oh, Darcy just told me how to get even with all of you. I don't have to hear a peep from any of you anymore. Okay, that's good. I'll put you all over here. If you want to talk, you have to apparently ask my permission. Okay, good. So anyway, when you get your oyster seed, if it's got that black line in it, you know it came from kind of that part of that original breeding of that system. So they're now bred to be resistant to a disease called Rosia virus. The reason they were dying was this disease that at the time they called juvenile oyster disease. We now know that it's a bacteria, and we've bred it out of the system. So that's what those black lines are about. Scallops have a lot of different interesting color morphs. Some of these aren't our bay scallops, but these down here are our bay scallops. This very neon yellow and orange color. Black, white, striped patterns of scallops. Our color. Well, I guess I gotta do some more muting here. Who do I have? Did I get them mute? I can mute everybody except for me. Huh? In case you guys don't know how to mute. But, oh. Mute. I'm muting you guys. There. Good. We're all learning how to do this. Look at the color of those scallops. There's a company called, they're not in business anymore. They were out of New Bedford, and they were called Taylor. And they only grew scallops. And they grew these scallops, and they had them in the most incredible neon colors, which, let me go back for a second. These ones here, these orange and neon yellow ones, were grown by Rick Carney in Martha's Vineyard to just see if they could tease out these beautiful color morphs. And what they found when they did that, they could get these beautiful looking scallops that are so pretty to see. It turns out that the predators can see them really well too. So there was super high mortality in these neon colors. And so Taylor was doing the same thing, but all of his scallops were always in lantern nets. They were never not protected. So the shell was almost as valuable as the meats that they were selling. They're so beautiful. The one that I worked on a lot in the past were these black and white striped pattern. I call them skunks or peace scouts. They can look like a peace sign too. A naturally occurring color morph that are actually the opposite of being neon that the predators can see you. Now you've got what's called disruptive coloration. So this is a kind of a camouflage for the scallops that breaks up their scallop shape and makes them, if they're in eelgrass or in some kind of an algae, they can be hidden there because they're mostly dark and with a striated pattern that breaks up the shape of the scallop. So that's a nice color pattern to have. And you can see so many of them there. How'd you get so many that had that pattern? But you can breed them to be 100% that color morph by this broodstock selection. So if you wanted to have all your scallops look this way, you could breed them into that over time. And I think, we haven't done this for a while, but if the commercial oyster grower, for instance, wanted to grow scallops as a polyculture, and they bred them to be this color and they all look the same, they would be able to control a lot better how they could sell this product, as far as selling them undersized. That you're not taking them from the wild; they're all hatchery reared. So that's something that we can kind of address again that we haven't looked at in a bunch of time. I got to do this on Wednesday. On Tuesday, we spawned clams, and we had what was it? It was, I think we had 21 female clams and 17 male clams, and I got to mark them and put the little symbol on them, and 21. So female 21. This was a female spawned in 2003. Here's a female spawned in 2000, 2002, 1999, and 2003. So there's a female clam that you can throw overboard, let it dig in, and when you go to go clamming for your broodstock, you can get these marked clams, and now you have a female clam that has actually spawned a bunch of years. So that's kind of fun. And I tell you that indelible marker is remarkable stuff because it stays on. You can refresh it, but I tell you, it really stays on there, so you can have your marked clam. And why would you want to mark a clam? Well, yesterday when we did our oyster spawn, we got 15 female oysters and 27 males. Now, keep in mind that males don't get off eggs, so you don't get a larvae from a male oyster. You just get the genetic. You get the sperm from the male, which is obviously going to fertilize the egg, but it's the females that give off the eggs that will make the larvae. So the females are really critically important. Like in human race, the females are important. The males are kind of, practically useless, except, right? I don't know. So we can tag them. If we were to choose 40 clams that were tagged, if I had my way, I would choose 30 females and 10 males. You get the genetic diversity of the 10 males, but you get mostly eggs. So it's a good way of choosing. And you might say, well, why don't you just spawn 200 clams and not worry about it? Well, I'm going to show you why it's difficult to condition too many animals. Here's a picture of scallop. This is a very interesting picture of a scallop because I have written here 2N and 3N. This right here, scallops are hermaphrodites their whole life, so they're both male and female. So the white here is the sperm, and the orange is the egg mass. Now, what's interesting is these two scallops were harvested on the same day, and this one, here's the gonad, and you can see that it doesn't look anything like this. The other thing you might notice is here's the adductor muscle, and look at the difference in the adductor muscle. So what's going on with these two scallops? This one is a regular, what's called a diploid, 2 sets of chromosomes. This one has an extra set of chromosomes. This is 3N, so this is what's called a triploid. And in triploidy, you basically have sterility, and so all the energy is going into this muscle. So if for aquaculture, if you just were looking for the muscle product, you'd want triploids for sure. If you're looking for enhancement, you couldn't use these because they would never spawn. So just later on, I'm going to talk about something that we did, a little experiment we did at Cornell with scallop conditioning. And just keep in mind the picture of these two gonads and adductor muscles, because an interesting thing happened in that experiment that I'll come back to. How's everybody? Everyone can hear it? Is it all right, Darcy? There? Looking at the, not really? Okay, I'm gonna have to work.
Yeah,
on it.
you're still a little jumpy, but you know, we can hear you.
Okay.
It's just a little struggle.
Well, maybe it's just I'm nervous or something. And you just heard me stutter. I don't know. Okay, so here are some conditioning tanks, and what we have is we put in a chiller, which keeps the water cold, and a heater that keeps the water hot. It's kind of like, you know, the Stephen Wright joke for my birthday, I got a humidifier and a dehumidifier, and I plug them both in and let them duke it out. That's what we do. We put a chiller in and a heater in and let them duke it out until you get exactly the temperature you want. It can't go up high, it can't go down low. And what we're doing is we put these animals in a tank of water at spring temperature, 21 degrees. We're talking 70, 72 degrees. And we'll hold them at this temperature for 6 weeks and feed them cultured microalgae. Because keep in mind, we're doing this in January. There's no algae in the water. The water temperature is 32 degrees. It's cold, and there's no algae in the water. So what we do is we set the animals up to think that it's spring. And what they do at this, they're very kind of simple creatures. They're very good at what they do. And one thing that they do very well is modulate the kind of growth that they put on based on temperature. So at spring temperature, they're putting on gonadal growth. They're ripening for spawning. And so what's interesting about that is you can trick them into that year round. So we can trick them into spring in January, and we can kind of trick them into spring in August. You just keep them at that temperature and feed them, and they think that it's spring, and they put on gonadal growth. So these tanks have to be cleaned every Monday, Wednesday, Friday, new water, put in the same temperature water, feed them. This is a feeding, this white thing here is a feeding manifold that's hooked up to the algae room. So, and the reason why I say a maximum of 40 or 50 is the trick of this is you must feed them very well, or else they aren't going to put on gonadal growth. They're just going to put on mate. They're just going to try to survive. So it's really tricky. They eat so much. You have to have a lot of algae to feed them. And so you can condition a lot of animals if you have a lot of algae. But I've seen a lot of hatcheries do a bad job because they just can't feed these things well enough. One way you can do a better job is feed less of them with the algae that you have. And so this feeding manifold is very important. And I think this is probably the single most important piece of the whole operation is having this automated. What we do is here's a continuous algae culture system. It's dripping algae into this bucket here. And the bucket has a sump pump with a float switch on it. And every time the algae level comes up and trips the float switch, it flows the algae to whatever you want to feed automatically. So you can set this thing up and walk away from it, and it will feed whatever you want to feed every couple hours automatically. And that's exactly how the shellfish want to feed. They don't want a lot of algae at 5 o'clock in the morning and not be fed for the rest of the day. If you did that, they would filter all of the algae out very quickly, and they'd spit most of it out, and then they'd wait for the next feeding. So that's very inefficient. This way is very efficient. They feed 12 times a day. If it comes on every 2 hours, they'll get a feeding every 2 hours. And that's exactly the best way to feed them. They incorporate that algae a lot better that way. This was this experiment I was talking about. We had a question about why scallops have eyes. And if you ask well, I won't demean anybody. I was going to say, if you ask a third grader why they have eyes, they'll say to see all the things that want to eat them and run away. And that's isn't actually quite right. What we hypothesized is that scallops have eyes to modulate their spawning capacity based on the seasons. Scallops spawn in the spring and the fall, and they only have an 18-month life cycle, so it's really important for them to what we call recruit into the fishery. They've got to spawn, and the spawn has to take to make new spat. And they only have 2 chances in life, pretty much, to ever do that. So they spend a lot of their energy on this spawning event. So the question was, if they have eyes and they're using it for spawning, can you manipulate that using light? So we set up an experiment of 24-hour dark, 24-hour light, and ambient. So here's 24-hour light. Ambient was above it, and the ones that are covered were 24 hours dark. And what we found out, you remember that slide that I showed you with the triploids and the diploids? We found out that in 24-hour dark, the scallops had huge adductor muscles and very small gonadal mass. And in 24-hour light, it was the opposite. It was that nice circus peanut orange egg mass and smaller adductor muscle. So they clearly used light for reproduction. And it was kind of fascinating. We actually published the paper, a SPAT member and I did that. We actually wrote the paper and got published. So when you're conditioning scallops, you really should use 24-hour light on them. That was that piece of plexiglass and 24-hour light. Now, after 6 weeks and they've been feeding and they're ready for spawning, you can set up the spawn. And what's funny is somebody just asked me, you say you're spawning oysters on Thursday. How do you know? How do you know? I mean, what do you mean on Thursday? How do you know they're going to spawn? And the answer is, we put it on your calendar. This is how you're going to. I'm just looking to see if I can adjust my microphone. I just found something. Internal microphone. Okay, never mind. But you can put it on your calendar and say, okay, we went clamming on January 1st. 6 weeks later is Valentine's Day. What better time to spawn than Valentine's Day? So that's 6 weeks later, and you put them in a tank, and we're going to manipulate them into thinking it's spawning time in nature. So what we do is we put submersible heaters in, and we elevate the temperature from I got it in Celsius here, but from 70 degrees to 83. So we're going up this dramatic rise from 20 degrees C, 28 to 30 degrees C. And what we're doing is, people sometimes say, I had actually, it was the Suffolk Times, way back when we started SPAT, and they wrote a little article, and it said, Kim Tetrault was playing God today. No, I wasn't. God. I mean, if I was, I would have sent a thunderbolt right in that reporter's direction. No, but we're not creating magic. We're just understanding how nature works and manipulating it and modeling it. So what I do, whenever I do these spawns, I always think like the oyster. And here's how I would think if I were an oyster. I just spent 6 weeks going from really cold water to the water increasing in temperature and algae increasing in volume. I've been feeding really well. It's nice 70-degree water. It's no longer winter. And then and ask yourself, if you've ever gone clamming or you've ever come out of spring and you've gotten into the water for the first time going clamming or oystering, and it's a really beautiful day, and the sun's beating down, and you're in there with your boots or whatever, and you're picking up clams or you're clamming or you're oystering, and you say to yourself, wow, the water's really warm today. It's like bath water because the sun's coming down and there's a shallow creek, and the temperature of that water might have increased by a whole bunch of degrees just in that morning. Well, that's exactly what we're manipulating with these heaters, that same effect. And something just happened in the last spawn. I learned something, I've been doing this for over 30 years, and I learned two new things on this week's spawning, which was kind of cool. One I had to look at experimentally, and one I literally had to look at. So the first one was, we did a little experiment with with the clams and the oysters, but with the clams specifically, half of them we took out of the water the night before, scrubbed them and left them out of the water. And the other half we left in the water, didn't scrub them, took them out that morning, put them in the spawning table to see which ones would spawn first. And I would have thought, because you didn't pick them up and disturb them and whatnot, that the clams that just came out of the water would have spawned first. And it turns out it was exactly the opposite. The ones that were left out of the water and scrubbed all spawned before the ones that were left in the water, which really surprised me. The only thing I could think of that I would like to experiment with is that I've always had a question about when you're spawning. You take all of these animals, you put them in a table all together, you raise the temperature up, and that's a very potent cue, like we talked about with that nice first hot spring day and the temperature coming up. But then something happens, okay? One of the animals is going to spawn first, okay? And the question is, what is the release mechanism? What's the cue for finally releasing the spawn into the water? And it kind of dawned on me, something I'd like to experiment with. In a clam bed or in an oyster bed, there might be some of these animals that are exposed at low tide, every tide spell. You know how when you're clamming at low tide, there's some clams that are right down at the edge, that there's no water on them. You go digging and you get your clams. So those are being exposed, not exposed, but they don't have water over them for a period of the day, every day. Are those the ones that release first? It would be very interesting to see, because just by leaving these clams out of the water for 14 hours, for some reason, and statistically, I'd have to do this more and more to prove it, but they all spawn first. And it's just very interesting because I never really understand what causes the first one. We always bet on it, by the way. We always bet on who's going to spawn first. That we raise the temperature up as it's getting to 30 degrees. We have a cool water hose. Once it gets to 30 degrees, we want to cool it back down a little bit. And then we also can chuck one of them and strip out the gonadal material and put it in the water for what we call a gonadal suspension and drop it in the water. That's pretending that one has already spawned, because I can guarantee you that gonadal material, let's say that was a male that we shucked and that's sperm, if there's a pheromone in there, there's some way that they're communicating, hey, somebody's spawning, we have to spawn. And they set up a spawning synchrony, which makes a lot of sense, because if all the females spawned on Monday and all the males spawned on Wednesday, you wouldn't get any fertilization. It would be done. They have to somehow communicate that it's a spawning event. So if we do the gonadal suspension and the temperature rise, we pretty much set them all off. What happened with both of these spawns that we did this week, they were so well conditioned, we didn't have to do the gonadal suspension. That one of them just started to spawn. first. We have the floating candle for ambiance. We have that's my rubber gooey duck voodoo icon that I got from my ex-sister-in-law for Christmas, that we perched on. That was another weird thing. We weren't getting this whole half of the table of clams to spawn. They just weren't going to spawn. And so we moved the gooey duck to the other side of the table, and they all started to spawn. So voodoo is important. Don't forget, voodoo means something. So here's our spawning equipment all in place. We have our submersible heaters, our thermometers, cool water hose, our floating candle, our voodoo icon, selected various music, including Barry White, as Vanessa would say. Somebody let Vanessa know, and so she knew that Barry White was playing. Have you ever noticed, I'm speaking to Darcy, that she's got all those Grateful Dead and Beatles books up on the...
Yeah.
And then you wait. So you wait until the first one spawns. Here's where you place your bet on which one's going to spawn first. I got $1.50. That's Mikey. That's back when he was a scrappy. I think that's Jeff watching. This was a long time. When you see the last slide, you'll say what the date is. I think it was 2005. This picture. Yeah. And you wait until one of them spawns, and then I say, and then it's showtime. And then what happens there is they start to spawn. I've got some spawning videos that don't work with this PowerPoint, but I think I can share my screen of some of the spawn, because you can definitely see it. You can absolutely see the spawn when it's happening. It doesn't. And then you can pull them out of the water and put them in separate beakers, and things start to happen. Now, the other thing I learned during this last one is that I can't see anymore. My eyes are getting bad. I'm getting old. I've discovered that I'm getting old. The picture of Dorian Gray totally fell off the wall this week onto the hatchery floor. So I used to easily be able to tell the difference between male and female. And now when it's in the beaker, we discovered a new way of figuring it out. You take your cell phone out and you put on the flashlight and put it over the beaker. And now you can see the difference of what happens with males is it gets very, very opaque, cloudy, kind of milky. And females, it looks more like a Viennese snow goblet, very grainy. And so if you take your cell phone with the light on and put it over the beaker, you can easily see the grains. The other thing that's interesting about when oysters spawn is that the males spawn. Let me see if I can get a picture of an oyster here. Hold on. Okay. When a male spawns, the spawn comes out the side in a stream of like smoke. When a female spawns, it puffs eggs from the front. So it'll be a big puff coming out the front. And if you see a spawn happening out the side, that's a male. So you can just pull that out and put that in a special spot. And when they puff this way, that's a female. So there are some ways of telling without using a microscope.
I shared a link with you, Kim.
What's that?
I shared a link with you that from Instagram, and it looks like I think it's a male clam spawning that Josh posted the other day on our Instagram account. So if you click on the link I sent you, you could share your screen with everybody.
Excellent. And I hear that was a very popular video. That's how bored people are in this pandemic. They queue up clam spawns, and that's big. So again, if you're wondering if they're spawning, it's pretty obvious that the water. I mean, when we did this yesterday, the male clams we had in a tote, you couldn't even see the clams through the spawn. It just went completely like a blizzard of gametes. So so you can separate them out there. And the reason why you don't let them all spawn in the tank and just let them fertilize there is you don't get good control. The males cast off so much sperm that it can just kill the eggs. You have to control that. By the way, each of these female shellfish can cast off millions of eggs per spawn. Oysters are the real what we call fecund. They're very prolific in their numbers. So the literature says upwards of 50 million eggs per spawn. So when we did our 15 female oysters yesterday, we got in excess of 250 million larvae the next day. So it's really remarkable, the numbers that are involved in this. And you can collect all the eggs. This is actually larvae. This is a mock-up of how you would drain down the spawning table. If you wanted to catch every egg, you could collect all the eggs. That's actually larvae. If you collected eggs, it wouldn't be that dark. But it's the same thing. You've got a screen. There's a screen on the bottom that would actually catch the eggs. 27 micron screen. It can catch all the eggs. So you can catch every single egg. This is why, by the way, shellfish cast off so many eggs. In nature, they cast off all these eggs in the water column. I mean, the chance of them even getting fertilized isn't that great. And then everything wants to eat them. So they're playing the numbers game. A female oyster might give off 50 million eggs, and maybe 4 of those make it to be a SPAT. So it's, you play the numbers out. In a hatchery, it doesn't work that way. You can catch and fertilize every egg and raise as much as you can. And then you look under the microscope and you see a little dot called the polar body, and you might see cell division. They split in half and they look like a cluster of grapes. And then you can put them in your larval rearing conical, which we fill up and we put them in there. And you raise your larvae. So that was 2006, 21 females, 23 males from just a random selection of oysters. You can see that the ratio was pretty good, about 50-50. And that would give you a full complement of eggs that you need to run your first spawn of larvae. And basically, you end up throwing or giving away a lot of this larvae. We can't even grow 250 million oysters. On Monday, I have to go into the hatchery, drain them down, size the larvae out, and then set the stocking density accordingly. And we might literally throw away 100 million larvae. And there's nothing you can do. You can say, well, why don't you just put them out in the water? Then they'll make it. Well, the water is basically frozen. It's 32 degrees. They will definitely not make it. But we can call up a couple of hatcheries. I called up Barley at East Hampton. Hey, you want some larvae on Monday? And so, you can spread the love around a little bit. But next lecture that we give will be on larval rearing. And you'll see why you can't grow all of them unless you had a lot more gear. And we have a lot of gear. We are capable of growing a lot. We'll probably run for this spawn over 20 million larvae. So, all we really need, we don't need millions and millions for SPAT, but we want to get better at this. If anyone wants to play any part of this, by the way, our drain downs, unfortunately, are quite early in the morning on Monday, Wednesday, Fridays. But we will be spawning and raising larvae certainly through May. So there are opportunities to see it spawn. Just let me know, because we're still in COVID restrictions. So if you want to come by, just drop me an email and we can figure out how to get people involved in some of this stuff. And that's kind of, the nuts and bolts of it. And I'll open it up to questions if anyone has questions. Oh, hold on. Let me see if I'm going to stop sharing my screen. And I'm going to see if I can, hold on, cancel. I want to close this. Let me see if I can do this. I don't save. I've got a movie here. Let me see. And let me share my screen again. Did that work? What do I have? What is this? Can you see that? Is that being shared? You see that clam, male clam? So
Yes, we can see it.
you can see the spawn there coming out of the excurrent siphon. I've got a better one. Hold on. Let me get a better one. Try one more.
You can go into the chat and click on the link I sent for Instagram because that male is spawning there, that clam.
Here's a good one. Hold on a second. Screen share. So that's a female, and the big clumps of eggs. I mean, just lots of eggs being expelled. It's also interesting about that. Did you see that? Was it playing? What's interesting about this, a clam has an in-current and an ex-current siphon. So one of them is blowing out, one of them is sucking in. And you can see during a spawn that they stop in current. Otherwise, it would just go, it'd be casting out and it'd be going back in. So while they're spawning, they seem to shut off their in current siphon. And that's kind of cool. Yeah, and Darcy sent the link, which is probably better footage than mine. And good. And if anyone has any questions or any comments or anything, feel free to chime in now, or just drink your wine.
Yeah, I have a question.
Hey!
How are you, Ken? So good to see you. So you said that you don't let them spawn in the tank together because there's too much sperm and it'll kill off the eggs. So how do you modulate that when you take them out of the tank?
Oh, so what we're doing there is we set up the tank. Everything's going. We're watching now. It starts off that we're all bored and we're all kidding around and we're all doing this and we're all doing that. And then once they start spawning, now all of a sudden, all eyes are on the table, looking for when a spawn comes up, and you say, "There's one male." You pick it up out of the tank. Now, again, I can't stress enough how shellfish are like humans in that the males are practically worthless. Okay, so
What's the matter?
I think I just figured out why I was feeding back and what was going on. I've got this Bluetooth thing on. Okay, anyway, so turn it off. Wouldn't that really bother me if that's what it was that was causing all the issues? You can't hear me any better now, can you? I'm gonna kill myself.
That's what it was.
Ah.
I
Okay,
think you
let's
sound
start
better.
over. I'm gonna go to this first beginning of the.
I think you sound much better.
I'm learning, okay? I'm learning. We're all in this together, darn it. Okay, Andrew, here's what's going on. So, am I still here? You see everybody? Okay. So you're watching now like hawks, and you say, okay, there's a male, and you pick it up, and that one will go into a tote we call the men's club, because they can all sit there and they can spawn in the men's club. The females will lift up and put in a beaker. So it's like female, pick it up, put it in a beaker. Now they're going to spawn pure eggs in a beaker. You can decant the eggs into a bucket, wash it off, fill the beaker back up. They'll keep spawning. The males are all spawning in the men's club. There you can take the whole bucket and put the whole men's club and pour it in a bucket. Now you've got all of the sperm intermixed from all the males. And then when you've got all your buckets of eggs that are unfertilized, you take a small amount of that pooled sperm and pour it in the bucket, toss it a couple times, wait about 15 minutes, look under the scope for polar bodies and cell division, and then you're all set. The ones that are left in the tank that spawned while you said there's a female, when a female spawns and it goes poof, and you say there's a female and you pull it out, they might have cast off 500,000 eggs into the tank. So at the end of the, you can siphon that off into that egg catch screen and catch all those eggs, and they will have been fertilized automatically because there's sperm and egg in there. But you still get better control. All those, I call that the table scraps. You collect that separately and you keep it separately, and your other is premium, and you control the fertilization rate with a theoretical pooling of all the genetic diversity from all the males. So that's why we do it that way. You don't have to do it that way. You could do it a different way. You could set up a very slow siphon on the spawning tank with new water coming in and some coming out, constantly catching everything in a screen. And you could do it that way. It's just a choice of how you do it. Now, I'll tell you an interesting thing. There's a movie called The Oyster Farmer where they show, I think it's from Australia or New Zealand, and it's not a documentary. It's actually like an R-rated film. It's kind of a funny film about oyster farmers in one of these countries, like either, let's say New Zealand. And when they go to spawn, they take all their oysters from the flats and put them in this huge swimming pool, and they're all spawning in the swimming pool. So that's when I asked a fellow from China how many scallops he used for broodstock, and he asked me, "You mean in metric tons?" Because they just spawned the entire bay. You know, it's like a lot of places will consider a spawning event everything in the bay and just set out SPAT collectors. So this is a controlled method of, let's say, a somewhat small scale hatchery. And, 200 million larvae, that's not that small, but it's not the same as, 64 billion larvae swimming around. So, but that's kind of how we control things with that. Did that answer any of your question?
Yeah, no, it did. But it sounds like you said you just throw a little bit in. Do you measure, or it's just, it doesn't really matter that much?
Here's some of this is, here's what happened. One year, I don't know if anyone's ever told you something about me. You get me going and I can blab and 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 blab. So one year I was doing a spawn, and I think we were filming it. Oh, you got that? Okay. So we were filming it, and we had this tremendous spawn. And I put all the eggs in the bucket, and then I had the sperm in that bucket also, and I took almost a coffee cup amount of sperm, put it in the bucket, swished it around, blab, 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 blab. And maybe 20 or 30 minutes later, I took a sample and looked under the scope. And what I saw was the egg there with like 10,000 sperm around it. It's kind of, and it immediately shot me the vision of me in Maine in the summer and gnats, or something, just completely encased. And none of those eggs fertilized. I killed the entire spawn from too much sperm. So if I had just stopped blabbing and took a sample and saw that I had put way too much in, I could have just run them through an egg screen, cleaned them all out, and they would have probably been all right. So what we did the last couple days was really put some in, stir it around,
take a sample in
Going
10
for it?
look for
I'm gonna
the,
wait for the music starts. If they
see-
do.
you see like 10 sperms swimming
I think
around
they
the
did.
egg.
How's it looking on the sky there, Rod?
Who's that? We're gonna have to mute you. Oh, we're gonna punish you in a minute. Okay, so you see like 10 sperms swimming around the egg and then you know you're good. But if you saw a whole cloud of them, you know you went too far. So it's a little bit, that's a safer way of doing it, because the other thing you don't want to do is say, well, I don't want to kill all of it with too much sperm, or I don't want polyspermy or any of that, and put too little in and nothing fertilizes. So that's kind of how we try to control it. Good?
Yep, thank you.
Anybody else?
Yeah, Tim, did I understand correctly that it takes the oysters 6 weeks or so of warming for them to put on gonadal material?
Well, but understand something that I might have confused you with. Let's say January 1st, we crack through the ice and go clamming and pull up 40 clams, or crack through the ice, pull up a lantern net, pull 40 oysters, bring them into the hatchery, and then put them in the same temperature water that they were in, like 34 degree freezing cold water, and just let it come up naturally overnight. And then the next day, put them at 70 and leave them at 70 for 6 weeks. So it's not a gradual warming that we never modulate it. We set it the next day and leave it at that exact temperature for 6 weeks. Now, keep in mind, when I say exact temperature, if you raise the temperature a little bit close to the end of that 6 weeks in your tank and go home, they can all spawn in the tank while you're in bed. So, and it's happened more than once, certainly in my tenure. So when they get really well conditioned after the 6 weeks, their hair trigger, they can be set off very, very easily by even a couple degree change. So even taking them out of the tank while you're changing the water, if the air temperature is high enough, it can raise the temperature of that oyster, and you put them back in and they might spawn. So they're very hair trigger, and you definitely want to maintain that temperature spot on. So does that answer that question? Kind of? No, what was the question then? You don't look convinced that I answered anything.
Well, how long does it take them? In other words, from week 0 to week 6, they become then reproductive, they're able to reproduce?
Well, you know, you're setting yourself up, Chris, unfortunately, for me to put you to the task of experimentation, which would be you take, and you can do, by the way, you're totally allowed to do this. This is what we do at SPAT. This is what we want to do at SPAT. You can take a batch. We're doing a SPAT spawn on Monday. Charlie has been conditioning oysters and he wants to spawn them. He's going to spawn them on Monday. And then you could bring in a new batch on Wednesday or whatever day, it doesn't matter. You could start conditioning them, and you could try spawning them week 3, week 4, week 5 to see how long does it take to actually condition them before they're ready. 6 weeks is totally arbitrary. So, you know, it's kind of a rule of thumb. 6 weeks, will they get, if you go 7 weeks, are they more ripe? If you go 5 weeks, are they less ripe? You can look at that. You can look at that. I mean, I'm giving you some rules of thumb that we use, a kind of a protocol, but I would be remiss to say that, yes, 6 weeks, that's the magic number, you know? And I'll tell you another thing. If you were to pull oysters out in on November 15th, say, and condition them for 3 weeks, they never really unconditioned from the summer. So it might only take 3 weeks to have them conditioned to spawn. What they're doing, I think, in that time period is they're adjusting. This is the fascinating thing about this to me, is that these critters are actually modulating the kind of growth they're putting on based on temperature. So when it's spring temperature, they put on gonadal growth. When it's warmer, they put on what's called somatic growth or tissue growth. So shell growth and visceral mass and all these things. But at a certain temperature, they're shunting their energy into the gonad. And in the winter, they're not doing anything. They're like me. They're just putting wood in the wood stove incessantly, waiting for this stuff to end and move on with the world. So you can look at that experimentally, and I can almost guarantee you that you could get a spawn in less time than 6 weeks. So, good. Did that answer a question, or did it give you incentive to want to experiment with it?
Yes, on both counts.
Good. Anybody else there? Good.
I think Janet had a question in the chat.
Oh, where is my chat? Hold on. I don't see my chat.
Yes, how would the shellfish ever spawn in the bay? Does the water get to 70 degrees?
Oh, absolutely. Oh, here's my chat. No, the way it works.
70 to me, Kim.
What's that? Hi
I
there.
said the water never felt 70 to me.
70 degrees, the bay got to be 85 last year. Crazy temperature.
Call me next time.
What? It did. I'm serious. I mean, the thing is, 70 degrees, the water absolutely, I mean, unfortunately, the water in our bays is in the summertime is getting remarkably warm. It's getting so warm that we have southern rays coming in that never came in. The cow-nosed ray never came. You want to hear something wild? Is Otto a participant? Is he here? Otto? I didn't see him, but Otto called me up yesterday or the day before. He said he went home. He was at the center doing the spawn with us. He goes home and there's all these police cars in his driveway. His heart drops down. He rushes inside. Judy had called the Bay Constable. There were 2 dolphins on his beach yesterday. Now, what are dolphins doing in not only in Jockey Creek now, but in general, you know, things are warming up. And now it doesn't feel warm. I hear what you're saying. It feels really cold. But, you know, nature's a funny beast when it comes to a couple degrees in the water. Humans don't, I mean, Janet, I totally hear you. I won't go swimming. I don't like cold water either, you know. But you talk to the scientists in Peconic Bay about what the water temperature was. This has been the issue possibly with the scallop harvest for the last 2 years. Where are our adult scallops? And it could be that the water temperature is just getting way too hot at a critical time for them. And it's bringing in predators and it's bringing in some other things. So yeah, it definitely gets up there. And even if it wasn't 70 degrees, you know, if let's just say hypothetically that everything was on the colder side, you're still talking about the difference of 30 something degrees to spring is going to, let's say it's 60, that's still 30-degree difference in temperature. So they pick up on that. A more interesting question might maybe be, well, what about down in warm climates where it never gets cold? How do they spawn? What are their cues? And that's a little trickier because down south in Florida and whatnot, apparently shellfish are kind of dribble spawning all the time because they don't have the same dynamic, what we would call in chemistry, the delta T, the change in temperature. 30 to 60, that's a delta T of 30 degrees. That's a lot. Down in Florida, it's like, you know, whatever, 80 to 83, okay?
Okay, great, thanks.
So if you want to go swimming, go to Florida.
No, okay.
Okay?
Thanks so much.
Good, no worries. Don't put all your eggs in one bucket. That's true, especially if you kick the bucket over, which has happened in the past. So good. Hey, we're learning something. I learned so many things. The other thing I learned was that, and I have an eye doctor appointment on Monday. I can't see eggs anymore. Oh, I told you that, the flashlight. So I learned about the flashlight thing. I learned about the trigger potentially being intertidal critters that are out of the water for a period of time, might be the first ones that trigger the first spawn. I learned that my Bluetooth thing shuts off my audio. And I'm learning every day, thanks to you guys. See, that's what happens. That's why we're all in one big SPAT family, so we can teach each other things. SPAT school. We're all SPAT schoolies. Yeah.
Is that
Good.
Kimmy? Hey, Kimmy.
Good. Yeah, there's Kimmy.
Hi, good to see you.
Good. Yeah, she gets to come to lectures now.
Yeah.
We're moving to Southold in June. We're going to be Southolders in June. We're very excited. Then I can go to the Marine Center even more than I do. Spend the night. Yeah. Good. How'd everyone do? Good. Thanks again. And you know how to get in touch with us. Everything's coming alive and things are getting better in the world. We should be looking good by, 2023 anyway.
We still have a question in the chat.
Oh, why aren't there giant oyster beds around commercial? Hi, Sean. That's going to be lecture 4. And what it is what allows any shellfish to settle into the environment, to actually metamorphose and take hold. The question was, why aren't there giant oyster reefs around commercial aquaculture places? It really depends on where you are. If you go to Wellfleet, there's oysters on everything there, giant reefs. You come to our place and you're occasionally seeing oysters set on other oysters, but these giant reefs won't exist in environments that didn't promote them in the first place. What's interesting about what environments promoted them in the past? Manhattan, yeah. Chesapeake, a couple places where prolific reefs. It's not going to be everywhere. I don't think the Peconic Bay ever had reefs to speak of. It's mud bottom, not really conducive. Horton's Lighthouse Sound had a huge oyster reef. Where is it now? It got buried, they say, in the 34 hurricane, and it never came back. I find that very kind of intriguing and almost hard to believe. But it has to do with things that we're going to discuss. And I wish I could answer that question, but it has to do with the environment of where they want to set. And you can try to promote it and spike it and try to enhance it. And I'll tell you, people have been doing this for a long time with a lot of money, and it's pretty challenging. I mean, those prolific oyster reefs off of Manhattan, how long did they take to get there? A long time. And it didn't take very long to wipe them out. So, I mean, if we were saying, well, can we have oyster reefs like we had in Manhattan? Yeah, maybe in 1,000,000 years. So you got to be pretty patient. But, there's nothing wrong with trying to build oyster reefs. Yeah, I'll tell you an interesting thing. You asked that question a bunch of years ago. This is maybe 20 years ago or something, 15 years ago. California made all of their old toilet bowls illegal. You had to have the 4-liter flusher. So they took all the old toilet bowls and apparently they busted them up and threw them over the Golden Gate Bridge. Okay. And 2 years later, there was a huge oyster reef. set up on those. So when I told that to the story of the SPAT people, the next week, everyone was bringing their toilets to the Marine Center. So don't do that. No, but the point being that they were promoting oyster reef by putting a calcium-based substrate, and there were oysters there, enough of the plume of larvae that they hit it like a magnet. And so, you know, it can be done. You would think that commercial oyster, the other reason, however, Sean, who asked the question, is that commercial oyster farm, when all of those oysters spawn, the larvae doesn't necessarily stay where the farm is. It travels. It travels with the tides, with the winds, with everything. So that whole plume of larvae can end up anywhere. The chance of it actually sitting there still for 2 or 3 weeks and going bonk right on top of the farm would be pretty rare, unless it was in a pretty enclosed embayment that water couldn't flush all the way out. So I make all this stuff up as I go along. You know, as long as any of it sounds good to you, we're okay. So sounds good enough to me. Good. How do we do? Was there another chat there? Nope. Nope. Good. Happy? Good. Well, if that's the case, stay in touch, stay warm, stay healthy, stay safe, and we get the information. Darcy's excellent at getting everybody notices that stuff is coming up, and we will have things will warm up by, you know, mid-March, April. We can get people their seed and the overwinter seed. We still are running 30 barrels of seed all winter long. So good. Stay in touch. Thanks for coming by. Thanks for helping me learn how to do any of this stuff.
Anytime.
Good, good.
Okay, bye-bye, Kim. Thanks.
Bye now.
Thank you.
Okay. See you, Darcy.
All right.
Bye,
Take care.
everybody.
Weekend.
You too.